Hello, and welcome to Lesson 9.1. Page 665 is our starting point, and here you can see that we have slope and different lines and different tables, and we will be working with graphs and plotting points. So we will be reviewing some slope and information like that that is important. But for now, let's go ahead and turn the page and talk about scatter plots. So right here we have two highlighted yellow words, which means we have two vocabulary words. So we have data with two variables or pairs of numerical observations are called bivariate data. Bivariate, that's how you say that. Now, a scatter plot shows a relationship between bivariate data graphed as ordered pairs on a coordinate plane. For example, the bivariate data set year and number of visitors can be displayed as a scatter plot. So a scatter plot means that it has the points on there. They're just points, and it may actually look like the points are scattered a bit. Example 1, make sure you follow along. 1. Construct a scatter plot of the number of viewers who watch new seasons of a certain television show. So right here, it's going to break it down for us. We have to make a scatter plot, which means we need a graph of some sort. So here, if you look, the horizontal axis, or the x-axis, so the one going left and right, side to side, it represents the number of seasons. So we're talking about a television show here. Now the vertical axis, or the y-axis, represents the number of viewers. And now we're going to graph the ordered pairs, seasons and viewers. So right here we have a graph. And in this graph we have all of these different numbers. We have season 1 had 31.7 million viewers. We have season 2, 3, 4, 5, and 6. All of these are different ordered pairs that need to be graphed on the graph, which is already done for you. First one is at 1, 31.7. So I go over 1 up to 31.7. So right here, all of these points are plotted on our graph, and they make what is called a scatter plot. And the reason we know that it is a scatter plot, they're not connected in any way, right? Scatter plots are not connected. These dots are individual and by themselves. Now, let's actually practice doing one of these together. It says construct a scatter plot of the weight of an alligator at various times after hatching. So let's reach back into our memory bank and try and remember what we did when we graphed and when we had tables like this. So here is a reminder. When you have a table, X stays on the left and Y is on the right. So that means that our X-axis, the horizontal one going left to right, has to be weeks. Make sure you're also labeling these. This is an example. If I write it, you write it. So that means that the one going up and down the y-axis, which is vertical, is going to represent the weight. And I'm just, that's bad. I'm just going to write sideways here. Weight. And it's always going to be like that on a table. If you are confused and you're not sure, please make sure you use your resources to find out. Now, the first point that we need to do is going to be right here, the very top, 0, comma. If you want to think about this line in the middle as being a comma, that might help you remember that these are ordered pairs. So all of these are ordered pairs. I'm going to end up graphing all of them. Those are my commas. So 0, comma 6. So 0 means I don't go over, but I do go up 6. So after that, I go over 9 up to 8.6. So 9 is not going to be on the line. It's really just an approximation here. 9 and 8.6 could be right about there. After that, I go 1810. So I find about where 18 would be, and I go up to 10. Next is 27, comma 13.6. So I go over 27, up to 13.6. Right about there. Oh, that's a little bit off. About there. Next is going to be 34.15. So I go over 34, up 15. Should be right about in the middle. 43, comma 17.2. Over 43, up 17.2. And then right here, 49, comma 19.8. So I go over 49, up to 19.8. All right, so this is your scatter plot. That's it. This is what a scatter plot looks like. It's got the labels and it has your points, and the points are not connected. All right, make sure that you are on this next page here, which is page 667. At the top, we have what is called a key concept, which means, hey, this is important. So let's read through these. The what we're talking about, first of all, is a type of association, which really just means a pattern. Like, what do we see here? So right here we have variable associations. So when you see these dots on a scatter plot going up, which, we can draw on a line here to show, hey, that these are going kind of upwards. And really, if we want to be more accurate, let's put one with an arrow, because it shows that, hey, that's going to go up. Now, a negative association, point your arrow downwards. Right here, this one with all of these random and scattered dots, no association. It's not positive, it's not negative, it's just nothing. And there's no obvious pattern. Now, one thing that might be important for you to note, if it is a positive association or it looks like this line is headed upwards, that means that X is increasing, or X gets bigger as Y gets bigger. Now, the opposite is true for a negative association. As X increases, so X is still getting bigger, Y is going down. So we're going to look at some problems that will be like that. And then down here, we come into what is known as linear associations. We all know linear lines. We should know linear lines. A linear line means that it is straight. Okay, so we can say right here that this example is a linear association because the data points lie close to a line. See how I could almost draw a straight line through there? Now over here we have nonlinear. The data points lie in the shape of a curve. I can't possibly draw a straight line through here. No matter where I start, it's just gonna be a mess. So I would have to curve it, which gives me a nonlinear data. All right, and at the bottom of that same page, it says you can analyze the shape of the distribution of a scatter plot to investigate patterns of association. So really right here, investigating patterns is what we're concerned with, because you can see here in this picture, we have a couple circles and pointers and all of that kind of stuff. We'll get to that. Now it says, if the distribution shows a positive or negative association, then the distribution can be classified as linear or nonlinear. The scatter plot below shows a positive nonlinear association. Clusters or outliers can also be identified. Wow, they just gave us a lot of information. Let's go ahead and start with the points themselves. So notice that none of them are connected. They're just kind of right here. And if you want to try and draw a line through it, we probably could try, but it's going to be a curved line. A curved line tells me it will be nonlinear. Now, this arrow is going up and to the right, which tells me it is a positive association. And now we have some kind of new vocabulary words. This word right here is an outlier. You can also kind of think of it as like an outsider, which means, hey, this point is kind of all by itself. Those are called outliers, and we'll talk more about those soon. And then another thing to note, and I'm going to erase part of this here, is when you see a cluster of points right here, a cluster or a collection of points that are close together. So there's quite a few here, and as your line continues up in a positive direction, it kind of dwindles down, and there's not quite as many. So in the area where there are a lot, that would be considered a cluster. Go ahead and turn the page. This is example 2, and example 2 is on page 668. We'll read through it together. It says, interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So we're going to be comparing associations and stuff. When it says to interpret, you should know that you need to give me some information about this. Like if I were not able to look at this graph, you would have to explain to me what it looked like. That would be a good way to interpret something. So right here, we have a variable association. Remember, variable association, if you flip back, means is it positive, is it negative, or is it no association? So we need to kind of look here. It looks like it could kind of be going up, maybe. It says, as the amount of memory increases, the cost increases. So they're talking about MP3 players here. We could also consider a phone or an iPod of any kind. If you get a phone that has a ton of memory, your cost is going to skyrocket, right? So if you can compare it to another phone that doesn't have quite as much memory, you could probably assume that the cost would not be quite as high. So that is the same in this case. Right here, it says the scatter plot shows a positive association. Notice how we're on the same line here on some of these, but we're going up in a positive direction. My arrow would be pointing upwards. Now, a linear association, if you check back, linear means it's either linear in a straight line or nonlinear, which is not in a straight line. It says the data appears to lie close to a line, so the association is linear. I could draw in a line here, and most of them would be about even, except for, we got that one about there. But it would be considered linear. It's not going here, 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 and then automatically up, or here, 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 and then down. It's not making a curved line. So right here, any other patterns you see. It says there appears to be a cluster of data. 1 to 2 gigabytes of memory costs between $30 and $75. There does not appear to be an outlier. So what they were saying is 1 to 2 gigabytes of memory. Right here and right here, since those points are so close together, those are considered a cluster. And they kind of group them all together, and they say, okay, if you get 1 gigabyte of memory, from 1 to 2 gigabytes of memory, it's going to cost you, maybe about $25 to about $75, depending on the device. So that is a pattern right there because that's a cluster. All right, let's try and do this example together. So remember, when you interpret things, there's really just kind of 3 different areas we're looking at. We're looking at variable associations, linear associations, and then maybe any other pattern. So I'm actually going to type so that we can read it, and it'll just be a little bit faster for us. Okay, so the first thing I want to look at is a variable association, and I'm just getting these words from right above there. You can see that the first thing they looked at on the example 2 was a variable association. So that's trying to figure out, is it positive, is it negative, is it going up or down? So right here we are interpreting the scatter plot of the data for the time elapsed and the temperature of water based on the shape of the distribution. So interpret. Start with a variable association. Is it going down? Is it going up? Is nothing happening? So if I were to just kind of follow along this line, it does in fact look like it's going downwards. So if I'm giving a variable association, I say, it really doesn't matter how you put it. You can say something like, it appears to have a negative association. Sorry for my typo. Because let me space it out. As the time increases, the temperature decreases. How do I know time is increasing and temperature is decreasing? Well, if I look at my x-axis, my x's are getting bigger as we go along. And if I look at my y-axis, my y's are getting smaller. That's why I just used the labels there. So I had variable association. Let's go ahead and do linear association. So linear association is, hey, is this in a straight line? And really, this appears to be an almost straight line. There's nothing really that makes too much of a curve there. It appears to follow a straight line is what we could say. And then let's see if we see any other patterns. Like there's no clusters, nothing is really grouped up together, and there are no points that are way out off by each other, so there's no outliers. So I would say this graph really only has a variable association and a linear association. Okay, let's go ahead and look at this one. Now, when I say scatter plot, this is the type of thing I think about because these really do look scattered. Okay, so we are trying to interpret these, which means to explain to me like I cannot see this graph. Okay, so it says interpret the scatter plot of the data for 2 weeks in May and the amount of ice cream sold at the shop based on the shape of the distribution. So the first thing that we looked at on the last 2 examples was a variable association. Let me get that in a different color for you. And remember, the variable association is trying to figure out, is it going upwards or downwards? Variable association, and take a look at this. This thing is a mess. It is quite literally a scatter plot. There is no pattern at all here. So we would say no association because there is no pattern. Now, the next thing that we need to do is look for any linear association. And remember that a linear association is it straight or is it curved? Association. So if we look at this one, I think you guys will all be able to tell there really is nothing going on here. We can't even say that we can't say it's linear, nothing is going in a straight line. And we can't even say it's non-linear because non-linear lines all have to have a curve to them. Linear or straight, if that was a straight line. But this scatter plot has none of that. So on this one, actually, the linear association, we can just say that there's none. And the other patterns, you can actually leave blank. If there are no variable association or no linear associations, you're not going to really find too many patterns. Maybe an outlier. That's it. All right, let's go ahead and look at this example here. Example 3 looks long. We're going to just kind of go through it because you can always come back and read these. It says the table shows public school enrollment from 1999 to 2010. So we have years since 1999, which are going up. So 0, 1, 2, 3, 4, 5. So that's 1 year from 1999. So that's 2000, 2001, 2, 3, 4, and so on. Now, they want you to construct and interpret a scatter plot of the data. If an association exists, make a conjecture about the number of students that will be enrolled in public schools in the year 2015. So right here, it's kind of putting it all together. You need to make the scatter plot, which we did in example 1. And then you need to interpret, which we just did in example 2. And then they even say to make a conjecture, which is similar to making a prediction. So constructing a scatter plot, which is right here, all they did was take these numbers and put them into a graph. Now, the different association and patterns, variable association. As the years increase, the number of students increases. Therefore, the scatter plot shows a positive association. See how this is headed upwards? Now, linear association, the data appear to lie close to a line, so the association is linear. If you were to draw in a line here, sure, it wouldn't be super straight over at all, if I can draw one. It wouldn't be super straight, but these would all lie very, very close to this line, and that's a straight line even. So right here, any other patterns, there's no clusters or outliers. So a conjecture, which would be a prediction, it says to make a conjecture about the number of students that will be enrolled in public school in the year 2015. Follow the pattern until the x value is 16. So right here, they're all the way down here, 16. You would take this and just kind of follow it along, and it looks like it would just kind of go up, 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 up. And right here at 2015 looks like what the enrollment would be. And so right here, they put about what we got. So it says there will be about 51 million students enrolled in public schools in 2015. So if you look, 51 million is right here. Now, that is just an estimate and a prediction. So even if you get a different number around, getting about the same as somebody else is just fine too. So there's an example on the back side of this. Let's go ahead and take a look at it. It says, interpret the scatter plot shown for the men's Olympic 100-meter freestyle swim winning times. If an association exists, make a conjecture about the winning time in the 2016 Olympics. So remember to interpret. Interpret means look at those different associations. So the first association, let me make sure that this is a color we can see. Now, the first association that we want to look at, they're the same ones we've been looking at this whole time, a variable association. And the reason they call it a variable association is because you're looking at x and y and comparing them. Now here we can see, okay, does this look like it's headed down or up, or is there really any association? And I think with this one it's pretty obvious to see that the variable association is going downwards, which means it has a negative association, which is what we're looking for. Now the next one is going to be the linear association, which means, hey, does this look like it's going to be on a straight line or not? And since if you want to like hold your pencil down from the first point and just draw on, these are, although these seem like they're very off, they are very close to this line whenever you look at it as the big picture. So the linear association, we would say, yes, it appears to be linear because the points are close to a line. And then I really don't see any other patterns. There's no clusters. There's nothing that's close together. And there are no outliers. They're not that. There's nothing crazy up here. Now, it says to make sure you do right here, make a conjecture about the winning time in the 2016 Olympics. Okay, so I have 2000 here. I have 2008. And then 2004 would be down here. Now, if we wanted to make a conjecture about that, which is like a prediction, I guess, we would have to just kind of follow our pattern. So it's just slowly moving downwards. So I think that if we wanted to just keep with the pattern here, it would stay just about the same. It's so very slow that it wouldn't move very much. Excuse me. So right about here is where 2016 would be. It's not very far. And it really wouldn't go down much at all. It would be within the 46 range. We could say it would be, I'm going to put conjecture, which is the same as prediction. You can say about 46 seconds will be the winning time in the 2016 Olympics. And even if you put something like 46 or 47 or 48, that's still within reason. It's very close to that prediction right there.